Good morning, pre-calculus. So today I'm going to talk to you, we're going to finish up the unit on vectors. So this is 5.3b, and we're going to do 5.3c on this video as well. So 5.3b just talks about properties of vectors. These properties are the same properties you always use. So this is commutative property. You can rearrange them and it still works. Commutative of addition, this is associative of addition, so you can change where the parentheses are at. Addition identity, inverse of addition, multiplication. Okay, so all of these still work. Okay, so these are just saying that you can still move stuff around, treat it just like numbers essentially. Okay, but the next big thing that we need to get into is unit vectors. So unit vectors have a magnitude or a length of 1, but they're in the same direction as v. So it is called a unit vector in the direction of v. So what happens is sometimes you don't want, you want to know the direction separate from how long it is. So in that case, you're going to have to break it out and make it a unit vector. And this is used in some applications in physics, in science, and in math. So the formula for that is just going to be the vector over the magnitude or the length of the vector. Okay? Another way to rewrite this is 1 over the magnitude or the length times the vector itself. Okay, so let's go on ahead and let's find a unit vector in the direction of -2, 5, and we want to verify then that the result has a length of 1. Okay. So the first thing that I always do on these is I always find the vector if I'm given 2 points first. Okay, and then the next thing I'm going to do is find the magnitude. So the magnitude, remember, is just my x component of my vector squared plus my y component of my vector squared, and it's the square root of that. So that's going to be the square root of 4 plus 25, so it's the square root of 29. Okay, so some people are a little bit more concerned about leaving these in radical form. I don't care if you leave it in radical form or change it to a decimal. If you leave it in radical form, though, you do need to rationalize the denominator. Okay, so we're going to go on ahead and we'll just leave this one in radical form for now. So now I'm going to go on ahead and I'm going to rewrite this. So all I'm going to do to rewrite this is it's the vector divided by that length. In other words, it's the x component divided by that length, and it's the y component divided by that length. And that's it. Okay. But like I said, let's rationalize the denominator. So really I get -2 square roots of 29 over 29, and it's 5 square roots of 29 over 29. Okay, so now in order to verify that the result has a length of 1, we can actually do 2 things. We can do the math, okay, and we can turn it into decimals, or we can do it by hand. So this right here is going to become -2 square roots of 29 over 29 squared plus 5 square roots of 29 over 29 squared, and it's the square root of all that, right? So we're just doing this, okay, to this vector now. Okay. So, you know, one half dozen the other. I think it's easier to do these ones right here. So I'm just going to find the square root of 29. Okay, so that's about 5.39. Now just remember, if we're doing it this way, it's going to be a little bit off. Okay, so our number is not going to be exactly 1 because of our rounding. Okay, so the square root of 29 is 5.39. So now I need to do -2 divided by, so it's going to be 2 divided by that answer, and I get -0.37. And then 5 divided by that 5.385. See, this is going to cause my stuff to be off a little bit, so it's going to be about 0.93. Okay. So now I have to square these, add them together, and take the square root of them. Okay, to check to make sure that it adds up. So to check it, I'm going to do -0.37 squared plus 0.93 squared. Okay, so 0.37 squared. Remember, if you put the negative in there, I don't usually because it's going to cancel it out anyways. But if you do, make sure it's inside some parentheses there. So that's going to be 0.14 plus 0.93 squared is 0.86. And square root of 0.14 plus 0.86 is about the square root of 1, which is approximately which is approximately 1. Okay, so we just verified that the length is 1. You're not going to have to verify this all the time, but it's just, an easy way to check and make sure that you did the problem wrong. So our answer was actually one of these two right here. That was our final answer. Well, not this one. It would actually be that one, right? But our answer was one of these two right here. Okay, we were just checking it down here to make sure. Okay, but you're not going to have to verify these all the time. Okay, so a standard unit vector is pretty similar. So a standard unit vector is I, where you just have the vector 1, 0, so it's going to the right, or you have the vector j, which is just going straight up. So we like to use these and we write linear combinations of them. So in other words, instead of, so if we have our I going this way and our j going this way, then we just write a combination so that we have our standard unit vector going in this direction in terms of I and j. Okay, so really all that happens when you do that, if I have a vector 2, 5, and I want to write it as a linear combination, that just means that that becomes 2I plus 5j. So really, I'm just taking it out of the little brackets, the little carets there, and I'm adding the I and the j to it. Okay, that is it. Okay, but what we're doing is we're making it a combination of this vector here that goes to the right and this vector of unit 1 that goes to that goes up. So that's why it's called a linear combination. So it says, let u be the vector with initial point 2, -5 and terminal point -1, 3. It says, write u as a linear combination of the standard unit vectors. Okay, so let's go on ahead and do that. So we need to find, first we need to find the vector. Okay, so we're going to find whatever, this vector v, okay, which is our terminal point minus our initial point. Okay, and remember it's the x's. Okay, and then it's going to be the y's from our terminal point. So make sure that you're starting at the terminal point and subtracting the initial point. So that's going to be -3, 8. Okay, so now when I write it as a linear combination, that's going to be v equals -3i plus 8j. So I just removed these two symbols and put an I and a j. Okay, so that's my linear combination. So we can do operations with linear combinations just like we do with regular vectors. So here it gives us two linear combinations. So these are just vectors. Okay, so this vector is -3, 8, and this vector is 2, -1. And it wants us to find 2u minus 3v. So the first thing I'm going to do is I'm going to find 2u. Okay, so that's going to equal 2 times -3i plus 8j. And 3v is going to equal 3 times 2i minus j. So now I'm just going to distribute. Okay, so 2u is going to be -6i plus 16j. Okay, and I'm finding 2u minus 3v, so I'm going to put a minus, and 3 times 2 is 6i, and that's going to be 3 times -1, which is going to be minus 3j. All right, so now we're going to go on ahead and combine these. Okay, so I'm going to get -6i plus 16j. Notice I put the negative sign out here. I have to remember to distribute that. Okay, so that's going to be -12i plus 19j. Okay, so that's my final answer. So I combine this just like I do with normal vectors. The last thing that we need to talk about is dot products. So if you guys have had me for any other classes, I've told you I don't like to use dots a whole lot when I'm multiplying. Sometimes I do, but I try not to, because then you get to these things called dot products, which is where you actually have a dot between them. So you see it's a dot, okay, between two vectors. Okay, the dot product comes out as a regular number. Okay, because what you do is you multiply the x's and you add the y's. Okay, so when you do that, it becomes just some number. Okay? So the properties of dot products are the same as for vectors. You can change the order of it. You can multiply it by 0. You can change where the parentheses are at. All the same stuff. So that does not change at all. So let's go ahead and let's find some dot products. So here it says find each dot product. So the first thing I'm going to do is I'm going to take the x's from both of these and I'm going to multiply those together. Okay? And I'm going to add to that the y's from both of these multiplied together. Okay, so now I get 4 times 2 is 8 plus 15. So my final dot product, which is a scalar, a number, okay, is going to be 23. And that's my answer. Let's go ahead and do this next one. So 2 times 1 plus -1 times 2. Okay, that's going to be 2 plus -2. So it's going to be 0. Okay, so if you don't get a number, a whole number, right? Like just a number, I guess not a whole number, but a number, then you've done something wrong. This has to be a number. It's not going to come out as a vector. Okay, so this one, I'm going to take my x's and I'm going to multiply them together. This is 0 times 4 plus my y's multiplied together. And that's going to be, oh, not 4, that's going to be 0 plus -6 is -6. Okay. So dot products come out as numbers. Okay, but let's take a look at what we do if we do some stuff to these dot products. Okay, so it says let U be this, V be this, and W be this. It says find each dot product. And then we're going to determine whether the solution is a scalar or a vector. Okay, so let's find this first. So we have to do inside parentheses first. So we're going to do U dot V. So that's going to be -1 times 2 plus, so I'm taking my x values, adding it to my y values multiplied together. So 3 times -4. So that's -2 plus -12, that's -14. Okay, but I'm not done. Now I have to multiply that by w. So now it's going to be -14 times 1, -2. Okay, so here that's going to give us -14, +28. So you notice when you multiply, remember when you multiply a scalar, so a number times a vector, okay? So when you multiply a number times a vector, okay, you get a vector. So our dot product was a number, we multiplied it back times a vector, and we got another vector. Okay, now let's do this one. So U times 2V, or dot 2V. So the first thing we need to find is we need to find 2V. So 2V is going to be 4, -8. Now let's go ahead and do our dot product. So that's going to be -1 times 4 plus 3 times -8. That's going to be -4 plus -24. It's going to be -28. Okay, so that was still a dot product. So we multiplied a number times a vector first, and then we found the dot product. So the difference there. So make sure you're paying attention as you're working these into what you're doing. Okay, let's go on ahead and find, I'm erasing this because I did a little bit of work on it and forgot. So let's see, this one says the dot product of U with itself is 5. What is the length of U? Okay, so when we say U dot U equals 5, okay, so we have U squared equals 5. Okay, so then U is going to equal the square root of 5. Okay. The last thing that we need to look at is the angle between two vectors. Okay. So the angle between two non-zero vectors, in other words, vectors that are not points, okay, is the angle theta. Theta has to be between 0 and pi, so between 0 and 180 degrees, and between its respective standard position vectors. Okay. So if theta is the angle between two non-zero vectors, u and v, then this is the formula. Okay, so you're going to find the dot product divided by the magnitude of them multiplied together, and that equals the cosine of theta. So you're usually going to have to do the inverse cosine. Okay. So let's go ahead and let's find an angle between these two vectors. So the very first thing I always do is I find the dot product, and then I find each of the magnitudes. Okay, so u dot v first. So 4 times 3 is 12, plus 5 times 3 is 15. So that's going to be, let's see, 25, 27. Whew, all right, so that's 27. Okay. Now let's find my magnitude of u. Okay, so that's going to be the square root of 4 squared plus 3 squared. So I'm just dealing with this one. Okay, so that's 16 plus 9. Okay, so that's the square root of 25, which is just 5. Let's do v. So that's going to be the square root of 9 plus 5 squared, which is 25, equals the square root of 25, which is just 5. Okay. All right, so, oh, wait, what did I do? 25, oh, that's the square root of 34. Yeah. So the square root of 34. All right, so now I'm going to go on ahead and just do the formula here. Okay. So we have cosine of theta equals u dot v, which is 27, over 5 times the square roots of 34. And I don't mind, you can change this to a decimal. You're gonna have to change it to a decimal anyways, because then remember we're gonna have to take the inverse cosine of both sides here. Okay, all of that stuff. Okay, so you're gonna get theta equals the inverse cosine of 27 divided by 5 times square roots of 34. Okay. So when you do that, you are going to get, I have no idea what you're going to get. So second cosine 27 divided by 5, and I'm putting the 5 times square roots of 34 in parentheses, okay, because I want it to do 27 divided by all of that. Okay, 5 and square roots of 34, and that gives me 22. So my theta is approximately 22 degrees. Okay, so that's my angle between these two vectors. Okay, so if I draw these and I have one at 4 and 3, so one's going like this and the other one's going like this, okay, that angle there is theta. So the measure between those two angles is 22 degrees, or approximately 22 degrees. All right, so these are the cases that we have. So if theta equals pi, then we know that cosine of theta equals -1. So that goes together. If theta is between pi over 2 and pi, then we know that cosine has to be between -1 and 0. So this is all going from our unit circle, right? So here's pi, okay, and at pi, cosine is -1. Okay, so same thing here between pi over 2 and pi, it goes from 0 to -1. So cosine can be anywhere from -1 to 0. So here, if theta is pi over 2, then cosine of theta has to equal 0, okay? Because up here at pi over 2, cosine of theta is 0. Okay, between 0 and pi over 2, it's going to be between 0 and 1, and if theta is 0, then cosine of theta is 1. Okay? So one thing that we want to look at is we want to see when vectors are orthogonal. Orthogonal means the same thing as perpendicular. Okay, so make sure that you get that in your mind and remember that. So orthogonal is perpendicular. The only time orthogonal is perpendicular is if cosine of theta equals 0 and theta equals pi over 2, which is a 90-degree angle. Okay? So if our u dot v is 0, then using our formula for, for theta, if u dot v is 0, then it's going to be 0 over some number, which is just 0. And cosine of theta equals 0 when theta equals pi over 2, which is 90 degrees. From 0 to pi over 2 is a 90-degree angle. Okay, so all we need to see is our u dot v 0? Okay, so that's what we're looking for if we're going to find out if it's orthogonal. So here it says, are the vectors orthogonal? So does u dot v equal 0? Okay, so let's find our u dot v. So that's going to be 2 times 6 plus -3 times 4, 12 plus -12, okay, and that is 0. So yes, these are orthogonal. Okay. So lots of different problems here on just make sure that you pay attention to your terminal and in your initial points when you're going through and you're solving these problems, because sometimes they say the opposite of, sometimes they swap, and you want to pay really close attention to that. Guys, have a great day, and I will see you all next time.